So in this lesson, we are going to look at the different ways at factorizing algebra expressions. So just if we think about what factors are, so if I was to take, for example, the number 4, and if I was to ask you to get the factors of 4, so they're numbers that will divide in evenly into 4. So for example, the number 1, the number 2, and then the number 4. So these are the factors of 4. And if I wanted to get, let's say, factor pairs, so factors, and then we have what are called factor pairs. So for example, these are the numbers that will both divide in evenly into 4, and then when you multiply them by each other will give you the number. So for example, if we take the factor pair of 2 and 4, so 2 multiplied by 4, so these two numbers will divide in evenly into 4, and then when you multiply them by each other will give you the number 4. And then also as well, if we take 1 multiplied by 4. So these are what are called factor pairs. So within this section, what we're doing is we're taking algebra expressions like this, like these here, and like the ones we're going to look at, and we are getting the factors of them. Okay, so they are terms that will divide in evenly to each of these, and then when you multiply them by each other, will give you the expression that we have here. So they're what are known as, so this is factorizing. And there's 4 general ways that you need to know how to factorize algebra expressions within Junior Cert, and that is, so we have a common factors method, which is the first method we look at, a grouping method, we have the difference of 2 squares, and then we have this what's called factorizing quadratics as well. And we're going to look at each of these in turn. So generally what we want to do when we're working with, when you're asked to factorize an algebra expression, what you want to do is you want to first of all try and use each of these methods here first. Okay, and then if you can't use any of these, so 4, 3, and 6 first, what you want to do is you want to start off then and work with this common factor method. So let's look at the common factor method first and how that works. So basically the common factor method is you look at each of the terms that's in the expression. So if we remember, for example, 6x, so this is what's known as an algebra term. You have the variable part, okay, the variable part, and then you have the number part, okay, or the coefficient. And basically what you want to do is you want to look at each of these terms and you want to identify the highest common factor. Okay, so what's the biggest value that will divide in evenly into both of these terms. Okay, so you want to get like the highest common factor. So if we look at it, so you want to open up a bracket like so, identify the highest common factor. So if we look at these two here, so a term that will divide in evenly into both of these would be 6. Okay, so the highest common factor is equal to 6. And what we do with the highest common factor is we put it on the outside of the term. Okay, like so. And then what we can do is we can, on the inside, you want to put, you basically want to put like what will get you to each of these terms. Or another way to find out is you can take each of the terms then and divide it by 6 or divide it by the highest common factor. So 6x divided by 6 is just going to be equal to x, okay, and then you put the x in here. And then if we take 18y, for example, so we look at that and we divide it by the highest common factor, which is 6. That will leave us with 3y. And it's plus 3y, and we put the plus 3y inside here. Okay, so that is factorizing using the common factors. So you look at each of the terms, you identify the highest common factor for each of the terms, which in this case it's 6. So it's the highest value that will divide into each of the terms that's in the expression. You open up a pair of brackets, you put the highest common factor on the outside of the bracket, and then you divide each of the terms by the highest common factor, and whatever your answer is, you put them inside the brackets like so. And then basically what happens is, so we've taken this and we've taken this expression here. So this expression here, and we have factorized it. So what we can say then is if we take this, so this is this factorized. So if we were to take this and multiply it out, so for example 6 multiplied by x and then 6 multiplied by 3y, it will give me back this expression here. Just like and similar to, for example, if I was to take, let's say we start off with this 4 up here, and then if I was to factorize it, I would get something like this. And when I multiply these by each other, it gives me the original number back again. So this is the same kind of thing we're doing, but we're working with algebra. We're working with algebra expressions. Okay, so let's look at the next. So let's look at the next one. So again, what we want to do is we want to, let me just change the color here. Let's go green. So first of all, we want to identify the highest common factor. Okay, so if we take this one here, so we look at each of the terms, so we want to open up a bracket like so. And here on the outside of the bracket, we want to put the highest common factor. So we look at like what would be the highest common factor in relation to each of these terms. Well, if we look at the number 3 is common to both. Okay, so 3 will divide in evenly into both. And then also then as well, if we look at b, for example, b is common to both. So 3b would be the highest common factor for both of these terms. So we put the 3b on the outside like so. So 3b. Then what we can do is we can divide both of the terms by 3b. So if we take 3ab and we divide that by the highest common factor 3b, that's going to give us, so the 3's will cancel out, the b's will cancel out, and it'll just leave you with a. And then we can put this a inside here. And then if we take the next term, so 3bc, and we divide that by the highest common factor as well, which is 3b. So again, the 3 will cancel out with the 3, the b will cancel out with the b, and we'll just be left with c, and that's plus c, so we can put the plus c in here like that. And again, that's factorized now, and what we can say then is that if I was to take this and multiply it by this, and then if I was to take it and multiply it by this, I would get back this expression here. So 3b by a gives me 3ab, 3b by plus c gives me 3bc, and that's the second algebra expression factorized. Okay, so let's look at the next one then. So the next one is this guy here, and let me just change the color again. So let's go with this color here, maybe this color. Okay, so what we want to do is, again, we look at the term, we look at, the expression, and we look at each term in the expression, and we try and identify the highest common factor. So the highest common factor is just the term that will divide in evenly into both terms in the expression, and we put this on the outside of the brackets. So if we have a look at this, we can see that 5, for example, would divide into 10 evenly, and 5 would divide into this 5. So the number 5 would definitely be part of the highest common factor. We can see that p, for example, is common to both. So 10 and p is common here, and p is common here. So we could put p in. And then we look and we can see that q, for example, is common to both as well. So q. So 5pq would be the highest common factor. And we put this on the outside here. So 5pq, like so. And then what we do is we take each of the terms and we divide them by the highest common factor in order to figure out what we put on the inside of the brackets. So if I take 10p squared by q, and if I divide that by 5pq, so the 10 will divide into 5 twice, so that's going to leave me with 2. Okay, so they'll divide in. So p squared divided by p will just give me p. And then q divided by q, these two will just cancel out, and you'll just be left with 2p. So the first part that we put in here is 2p. Okay, then we take the second term, and again we divide it by the highest common factor. So we have 5pq, like so, and we divide this by the highest common factor, which is 5. That should be q squared. So 5pq divided by that, and that's going to be equal to, so 5 divided by 5, they'll cancel out, p divided by p will cancel out, and then q squared divided by q will just leave me with q. And then that's plus q, so I can put the plus q in here like so. Okay, so again, remember, if I was to take this, so if I take this term, multiply it by this, it's going to give me this guy here. And if I take this term, multiply it by this, it's going to give me this guy here as well. So that's the first method of factorizing that you need to know and you need to be comfortable with, and that is factorizing by the common factors method. So you look at the expression, you identify the highest common factor for the expression, you open up brackets, and you put the highest common factor on the outside of the bracket, then you divide each of the terms by the highest common factor to understand the terms that you put on the inside of the bracket, and then you can check then to see if it's correct by, so if I multiply this by this, I should get that. If I multiply this by this, I should get that. So that's the common factors method. So factorizing using the common factors method. So the next method then that we want to look at, if we move down here, so is the factorizing by grouping method. So again, this is very similar to the common factors method, except with this you're going to have like bigger expressions, and what you're basically trying to do is you're trying to group them together, and then you can, each of the groups, you can then use the common factors method to factorize it. Okay, so this method here, so the grouping method, how will you know when to use it? Well, generally you'll be given like an algebra expression like this that has at least four terms in it, and well, sometimes it can have less than four. And when it looks something like this, there's a high probability that you can use this grouping method in order to factorize this term. So the first thing you want to do is you want to look at each of the terms, and you can arrange them or rearrange them in whatever way you want, so that two of the terms have like common factors in both. So if we have a look at this, so we can say that this pair here are the first group because they have common factors. So for example, this one has b and this one also has b. And then if we take the second one, then we can take it as these two here. So we have group 1 and group 2. Okay, so this one again has common factors. We have 3, and 3 would also divide into 15 as well. So again, the same thing we do as we've done with the other one. So we want to open up our brackets. So open up our brackets like so, and then we're going to have our brackets open here as well. And outside here, we're going to put the highest common factor for each of the groups. So we look at this one here and we see what's the highest common factor. So the highest common factor is going to be like what would divide into both. So we can see it's likely to be b, because b will divide into each of these terms. So if I put b here as the highest common factor, and then again what I want to do is I want to divide both terms by the highest common factor. So if I take ab and I divide that by b, let me just actually put this over here out of the way, it's a bit tidier. So if we take ab and I divide it by the highest common factor, it's b, that's going to leave me with a. So again, a will go in here. If I take the next term, so 5b, and I divide that by the highest common factor, which is b, that's going to leave me with 5, and that's plus 5, so I put the plus 5 in here. Okay, so that's the first group. That's the first group factorized. Then I want to look at this second one. So this second one here, and again I want to look at each of the terms and identify what's the highest common factor. So if I look at, so 3 for example will divide into this, and 3 will divide into 15, so I'd say 3 is the highest common factor. So again I put my 3 out here, and this is plus 3, so it's going to be plus 3. And then what I want to do is I want to divide each of the terms by the highest common factor to figure out what goes inside the brackets. So if I have 3a and I divide that by 3, that's just going to leave me with a. And if I take 15 and I divide that by 3, that's just going to leave me with 5, like so. So this a, I put it in here, so a plus, and the 5, I put the 5 in there. So you'll know you're right with this one when you have, so if we look at this now, so we've taken this and we've grouped it, and then we factorize each of the groups. And what you'll see is that you'll have a factor pair that is common to both groups. So for example, this is b times a plus 5, and then this is 3 times a plus 5. So what we can do now is we want to end up with, so we can open up two brackets, so we have something like this. And in the first bracket, we want to put each of the highest common factors that are on the outside here. So for example, this would be b plus 3, b plus 3. So I'm just taking these from here and here. And then on the inside then, on this bracket here, I want to put each of these common factors to both of the groups. So it's a plus 5. Okay, so how do we know that we're right then? So basically, if I multiply this by this, and this by this, and then if I multiply this by this, and this by this, I will get this full original expression here. Okay, so that's the factorizing using the grouping method. So we're taking basically what we've done with the previous method, and we're using that. But what we do is we take this like big algebra expression, we break it up into groups. Each group will have the highest common factor, so we factorize it using the group method, and then we get down as far as here. And then what we do is we open two brackets like so, and we put the two highest common factors in the first bracket, so the b and the 3, and then we put these two here, the common factor to both, in the second one. So that's factorizing using grouping. So let's have a look at this next one. Okay, so let's look at the next one. So again, we can see here we have at least 4 terms, so it's very likely when you have something like this in your junior cert, you're going to be using the factorizing by grouping method. So the first thing you want to do is identify the two groups. So if we take, for example, this term here and this term here have common terms in each, so this has a and this has a, and then if we take this one here, so this could be the second group because it has common terms, so it has b and it has b in it. So again, what we want to do is let's factorize the first one. So we open up our brackets here like so, and then we're going to put the highest common factor out here. And then if we take the second one here, so again, we're going to have our space for our highest common factor, and we're going to put the highest common factor out here. So the first thing you want to do is you want to identify what is the highest common factor. So let me just put it up here. So highest common factor is equal to, so if we look at both of these, so a will divide into this term and a will also divide into this term as well. So what we can say then is that the highest common factor is a. And then what we want to do is divide both terms by the highest common factor. So if we, maybe I'll do this down here. So if we take an divided by the highest common factor, that's just going to be n. So the n goes in here. And then if we take the second term, so minus 5a, and we divide this by a, okay, so these will cancel out, and that's going to be minus 5. And then we put our answer in here, so minus 5. So that's the first group factorized. So then we move on to the second group. Sorry, now I should put that highest common factor as a. The second group then, so again we look at each of the terms, so we want to identify the highest common factor. So what's the highest common factor for minus 5b and plus bn? So the common factor is going to be b, because b will divide into both evenly. So we put, and this is plus b, so we put the plus b here like so, and then we take each of the terms and divide it by the highest common factor. So minus 5b divided by b, that's going to be equal to, so these will cancel out, it'll just be minus 5. And then if we take bn and we divide this by b, that's going to be, so these will cancel out and we'll just be left with n. So again, we put these inside here, so minus 5 and then plus n. Okay, so it looks something like that. So now we can see that we have these highest common factors. Now this is minus 5 plus n, but this means this is also the same as n minus 5. Okay, so you can easily just rearrange it like that. So let me just bring this down here, and then we have this guy here, which is a times n minus 5. Okay, and let's put the plus in here as well. So what we can see now is that we've taken each of the groups and we've factorized it. And then what we want to do is the last part, then we're going to have, so you're going to have two brackets like so. And in the first bracket, you want to put the highest common factor for each of the groups, which in this case is going to be A, and then plus B. And then in the second brackets, you want to put the common factor to both, which in this case is going to be n minus 5. So n minus 5. And then again, so how do we know we're right in relation to these? So this multiplied by this multiplied by this, and then this multiplied by this, and this multiplied by this. When you multiply them out, it will give you this original expression here that you started off with. And basically what we've done is we've taken this complicated expression and we've simplified it into two terms that when they multiply by each other give you this expression up here. That's the factorizing by grouping method. So the next method then is using the difference of two squares. So in order to kind of understand this and work with this, let's just put down some important numbers. So if we take, so for example, the number 1, the number 4, the number 9, 16, 25, 36, and 49. So these are what are known as square numbers. So what we can do is we can write them in square form. So for example, the square, if we write 1 in square form, it's just 1 to the power of 2. So 1 by 1 gives me 1. This is 2 to the power of 2. So 2 by 2 gives me 4. This is 3 to the power of 2. So 3 by 3 gives me 9. This is 4 to the power of 2. So 4 by 4 gives me 16. This is 5 to the power of 2. 5 fives gives me 25. This is 6 to the power of 2. 6 sixes are 36. And then this is 7 to the power of 2. So 7 sevens are 49. So these are what are known as square numbers. Now when we're dealing with the difference of two squares, so difference means minus. And then two squares means, for example, we can take the two terms and we can write them in square form. So that's what we mean. That's what we're talking about. So that's how when we look at these. So if we look at these two here, we can see there's a minus between them. We can see the minus sign here between them. And then we can look at each of the terms and we can see that we can write them in square form, just like we can write each of these numbers in square form. So if we take this method, so basically what we're looking for is we're looking for a minus, so we can see that we have a minus here, and then we're looking for like two square numbers. Okay, so the difference of two squares, so we can see that the 9 here, for example, is a square number, and the 4 here is also a square number as well, so we can write these in square form. So what we can do then is we can factorize this using the difference of two squares method. So we basically open up two brackets like so, and we make this one plus and this one minus. So we think about what would 3 to the power 3x squared, like what would be the factors of this. So two terms that when we multiply them by each other will give me 9x squared. So the first one will be 3. So if we take 9 for example, we can write 9 as 3 to the power of 2. So we could write this as 3x. So we put the terms for 9x squared in the first part of the bracket. So this would be 3x, sorry. So 3x multiplied by 3x will give me 9x squared. And then we look at the next one. So for example, if we take minus 4, so again, what's the square for minus 4? It's going to be 2. So this would be 2, and then this would be 2. And what we can see then is we can check this, and we can see that, so if I multiply this by this, and then if I multiply this by this, and then this by this, and this by this, it's going to give me back this original expression. So this is what's known as the difference of two squares method. So then if we take this second one here, so again we want to look at the expression and see, do we have a minus sign? So we do, we have a minus sign here. And then we want to look at each of the terms and see, do we have a square number? So 25 is a square number. It can be written as 5 to the power of 2. And 81 is also a square number as well. So 9 by 9 will give me 81. So again, we open up our two brackets. Let's open up our brackets like so. Just make plenty of space here. So again, we put in, and we put a plus, and we put a minus. So we put in the first space, if you like, on the left hand side in both of these, in both brackets, we put the factors that when multiplied by each other will give you this term. So for example, it would, so if we take, so 5a, okay, multiplied by 5a, so 5a by 5a would give me 25a squared. And then if we take this one here, so minus 81b squared, so again we think the numbers that multiply by each other that give you 81 is 9, so it's going to be 9, and then the terms that multiply by each other will give you b squared is b by b, so this is going to be 9b multiplied by, so plus 9b multiplied by minus 9b, like so. Okay, so again, how do we check this out and see if it's right? So 5a by, we multiply this by this, this by this, this by this, and this by this. So 5a by 5a gives me 25a squared, and then 9b by minus 9b gives me minus 81b. Okay, so that's the, so again, that's, if we take this expression here, that's how we would factorize it using the difference of two squares method. Okay, so let's look at the next one. Now, if we have a look at this one here, so what we can see is if we look at the numbers here, so we have a minus sign. Okay, so we have the minus, the difference, but then we can see that neither of these are square numbers. Okay, so it's like a number that can be written in square form, like these ones down here. So what we'd have to do with this one is we'd have to first of all factorize it using the common factor method. So if you can't use the difference of two squares method, you want to kind of go back and try and simplify it and use the common factors method. So what we can do is we can look at each of these terms and we can identify, first of all, what's the highest common factor. And if we take 12 and 75, so the highest common factor for both of these would be the number 3, for example. And then what we can do is we can open up a pair of brackets like so. We can put our highest common factor out here. And then what we can do is we can divide each term by the highest common factor. So 12x squared divided by 3 is just going to give me 4x squared. And then minus 75y squared divided by 3 is going to give me minus 25y squared, like so. Okay, so now what we can see now is that if we look at each of these terms inside here, they are square numbers. Okay, and we have then the difference of two squares. So what we can actually do now is we can factorize these two numbers in here, these two square numbers, using the difference of two squares method. So what would that look like? So we'd put our 3 out here, like so, and then we'd open up our two brackets. So we'd have, let's say, so the factors of this 4x squared, and we put our plus and our minus. So 2x by 2x, so 2x by 2x would give me 4x, and then minus 25y squared would be, so minus 5, so it would be 5y, and then 5y here. Okay, so we can see that first of all, if we multiply this by this, this by this, this by this, and then this by this, it will give me what's inside the bracket here. And then if I multiply then everything then by 3, it'll get me back here to this method here. So the next method of factorization we want to look at is factorizing quadratic equations. So if we take this guy here, so this is what's known as a quadratic equation. So we have like the highest power on the variable is x to the power of 2. So this is what's known as a quadratic, and this is how we identify it. So we need to be able to factorize quadratics. So the first thing we want to do is we want to open up our two brackets like so. Now what we have is, so we have the place on the left, and then we have this place on the right. And then in the middle we're going to have the signs. So the first thing you want to do is you want to look at this first term, and you think about what are the factors of x squared, and they're the ones that will go into the place on the left. Okay, so the factors of x squared would be x multiplied by x, and then you also have let me just put down here, so minus x multiplied by minus x. Okay, so you're looking at this and you're seeing, okay, what two terms when I multiply them by each other will give me x squared. So if we take x by x, so we put these in here, so x and x, so x by x gives me x squared. Then what we want to do is we want to look at this last number here, and we think about what are the factors of, or factor pairs of 12. So we have, for example, 12 multiplied by 1, so 12 multiplied by 1, that's one factor pair. We have 6 multiplied by 2, that's another factor pair, so it'll give me 12. And then we have 3 multiplied by 4. Okay, so these are factor pairs, so each of the numbers will divide in evenly into 12, but then when you multiply them by each other, they give you the number. So now we have to identify what do we put here in the left-hand side. So basically what we have to do is we want to look at the numbers and we want to see what pairs that when I add or subtract them from each other will give me this middle number here, plus 8x. So we look at these and we see if we take 12 multiplied by 1, and if we add these two together, so 12 plus 1 is going to be equal to 11. So 12 plus 1 is equal to 11. Okay, so it's not going to be those pairs there. If we done 12 minus 1, for example, that would give us 11. 12 plus 1, that would give me 13. So it's not going to be these two here, so we can rule those out. If we take the next one, so if we add or subtract them from each other, so 6 minus 2 will give me 4. Okay, and then you have 6 plus 2 will give me 8. So 6 plus 2 is equal to 8. Okay, so that looks like a good one. That's what we want. So when we add them together, we want to get this number here. So then what we can do is we can look at the signs, so we can see that we want to, when we multiply them by each other, we want them to give this plus sign here. So we can see that it's going to be 6. So this is going to be plus 6. And then this is going to be plus 2. Okay, so we're using these factor pairs here. Okay, so now we can see that we have a factorized, and how do we know we've a factorized? Well, when I multiply this out, so x by x gives me x squared, x by plus 2 gives me 2x, 6 by x gives me 6x, and then 6 by plus 2 gives me 12, and then if I add the two x's together, that will give me 8x. So this is the factor pair for this quadratic expression here. Okay, so let's look at this one here. So again, we want to, like, what are the factors that when I multiply them by each other will give me, what are the factors for x squared? Okay, so it's going to be, so you have x by x, and then you also have minus x by minus x. Okay, so we open up our brackets down here. And in the first place, we put in the factors that when multiplied by each other give you x squared, give you this term here at the start of the quadratic. So that's going to be x, and that's going to be x. Now we want to identify what goes in the right hand side, and that is related to this number here. So we look at the numbers that when multiplied by each other will give you 18, and then when added together will give you -9. So if we take, for example, the factor pairs for 18, so we have 6 multiplied by 3, we have 18 multiplied by 1, and then we have 9 multiplied by 2. Okay, so and then we want to think about, so if we add or subtract the numbers, we should get this number here. So if we take, for example, so 18 plus 1 would give us 19, or 18 minus 1 would give us 17, so it's not going to be these ones here. Okay, so it's not these. 9 plus 2 would give me 11. 9 minus 2 would give me 7, so again it's not this one here. So it's going to be this one here. Okay, so 6 by 3 gives me 18, but then if I add 6 and 3 together, it gives me 9. Okay, so it's going to be these guys here. So we'll use these. So we can put the numbers in. So we can put in, for example, 6 and 3 here. And now we need to think about the signs. So we want to have it so that when we multiply them by each other, they will give us this number here, but then when we add them together, they will give us -9. So if I was to put in plus and plus here, so x by x gives me x squared, x by 3 gives me 3x, 6 by 3 gives me 3x, and then if I add the two of them together, it's going to be +9 and not -9. Okay, so what I want to do is I want to change the signs because that sign won't work. And if I try two minuses, so minus and minus. So again, x by x gives me x squared, x by -3 gives me -3x, -6 by x gives me -6x, -3 by -3 gives me +18, and then if I added the x's together, it gives me -9. So these ones here are these are the factor pairs for this quadratic here then as well. Okay. So that is the 4 methods of factorization that you need to know for your junior cert higher level exam. Okay, thank you for listening.